For this tutorial, we're not going to be looking at the solving of linear systems, but we're actually going to take a look at what happens if you have a solution for a linear system. Is there a way that you can verify or double check that you actually have a correct solution? That may mean that you've been given a solution and you just have to find out whether or not it's actually a valid solution, or it could be that you've come up with your own solution and you want to have a way to double check that your work was actually correct. So, quick refresher. First of all, when we talk about a solution in general, a solution is a value or values that make the equation true. So that's the first thing we need to remember. Now, in the case of a linear relation, a solution to a linear relation is really saying a point on that line. So when we talk about a solution to a linear relation, we're talking about a point, and that's a point xy. If you have multiple linear relations, normally we'll be dealing with two linear relations, but if you have multiple linear relations, then you have a linear system. And a solution to a linear system, it's still a point xy, but the difference is that that point has to be on all of the different lines, or it has to satisfy all of the different linear relations. So we're going to look at a method that will allow you to step by step go through and check that each of your linear relations has a point xy, a specific point xy on it. And this is called verifying your solution. So we're making sure that a solution that we come up with, or a solution that we're given xy, satisfies all of the linear relations in our system. There's a number of steps to go through to do this. I know it looks like a lot, 6 steps here, but the thing to keep in mind is that these steps are actually, each one of these steps is very short. So the best way to illustrate this is I'm going to do a few examples to show how each of these steps is put into action. Okay? First example. In this case, we have two equations, and I've been told, so I didn't have to solve these myself, I've actually been told that negative 1, 2 is a solution. And remember that this is always written in the order xy. So the x value is negative 1, the y value is 2. I want to show that that's a solution to this system of two equations. So the first thing I'm going to do is pick an equation to take a look at. So I'm going to call this equation number 1. So I've picked an equation. I'm going to isolate the left side and right side of that equation. So equation number 1 is y equals 3x plus 5. The left side of that equation is just the value y. The right side of that equation is equal to 3x plus 5. And when you are doing a verification like this, you must isolate the left side and the right side. That's non-negotiable. Probably the single biggest mistake that students make when they are verifying a solution is that they try to do it all just using the equation rather than breaking it up into left side and right side. But because we are not sure that this solution is correct, so that means we're not sure if the point 1, 2 is, or sorry, the point negative 1, 2 makes this equal sign true. So we can't assume that. That's why we break things up into two pieces. We test the two sides independently. In this case, the left side is equal to the y value. The y value is equal to 2. So the left side is equal to 2. The right side is equal to 3 multiplied by the x value, which is negative 1, and then add 5. 3 times negative 1 is negative 3 plus 5, and negative 3 plus 5 is equal to 2. So the left side is actually equal to the right side. So I substituted my value into the left side and right side, and now I compared the left side and right side, and they are the same. So that means I verified this first equation. The next thing I need to do is repeat the whole process for the second equation. So now I'm going to pick another equation. That's equation number 2. Equation number 2 says x plus y is equal to 1. The left side of that equation is x plus y. The right side of that equation is equal to 1. So x plus y, the x value was negative 1, plus the y value was equal to 2. Negative 1 plus 2 is equal to 1. The right side is already done. So isolate left side, right side, substitute the x, y into the left side and right side, compare left side and right side. In this case, left side is actually equal to right side. Check. Equation number 1 has been verified. Equation number 2 has been verified. So therefore, we can now say that the solution that was given to us, negative 1, 2, is a solution. And that's it. We've done a formal verification. Let's take a look at another example. In this case, this is another way that you can lay out your verification. I just want to point out to you that sometimes you're going to be asked to do a verification as part of a larger question. So you may actually be asked, as it is written here, you may be given your system of equations, and you actually may be asked to do the solving yourself. In this case, I'm going to kind of fast forward that. I'm not going to solve this. I'm going to give you the solution, or at least I'm giving you what might be the solution. Remember, this may be the wrong answer, but we're going to verify whether or not this x value and this y value is actually correct for these two equations. So we're going to pick an equation. So I'm going to start over here on the equation y equals 3x minus 2. I'm going to isolate the left side and right side. The left side is equal to y. The right side is equal to 3x minus 2. I'm going to substitute in my x and y values. So the left side is equal to just the y value. That's equal to 4. The right side is equal to 3 multiplied by the x value, which is 2, minus 2. I just want to point out to you here, notice that in this case, and this was also true in our previous example, you're not always going to be using the x and y values in both sides. This left side only has the y value. We don't do anything with the x value. The right side only has the x value. We don't do anything with the y value. 3 times 2 is 6 minus 2 is equal to 4. Left side is equal to right side. So let's just make sure. So I have substituted and I've compared. Now I'm going to repeat. So I'm going to pick an equation. That's x equals y minus 2. I'm going to isolate. The left side is equal to x. Right side is equal to y minus 2. The x value is equal to 2, so that means the left side is equal to 2. The y value is equal to 4, so this becomes 4 minus 2, and 4 minus 2 is obviously 2. The left side is equal to the right side. So I've subbed and I've compared, and now I do my final comparison, which is I notice that the left side was equal to the right side over here. The left side was equal to the right side over here, which means the left side was equal to the right side for both equations. That means the solution 2, 4 has been verified in both equations. And we can just write a very simple final statement. Therefore, 2, 4 is a solution. And one final example. Now this is actually an example from a lesson I did on graphing, solving linear systems by graphing. And to the right you can see I have a computer generated graph. There's actually a small typo in that. This is not supposed to say 2/3, this is supposed to say negative 2/3. And so the solution that I found graphically, but I actually found this using software, was negative 2/3 for the x value and 8/3 or 2 and 2/3 for the y value. But if you had done this by hand, then you would have been confronted with the idea of trying to figure out where does this dot lie above the x-axis and where does this dot lie next to the y-axis. So if you take a look at the numbers I have here, negative 2/3, and if we go down here, well, it's between 0 and negative 1, and it's more than halfway, so negative 2/3 seems like a reasonable guess. But if you were doing this by hand, that's all it would be, is a guess. The same thing is true here if I go up. Well, it's between 2 and 3, and it's a little bit past halfway here, so it's a little bit past 2.5, so 2 and 2/3, which is the same as 8/3. Now in this case, I know that this is actually the correct solution, but once again, if you were trying to figure out whether or not your guess was a good one, you might go ahead and put that in here. So let's go ahead and follow our steps. And I'm going to pick an equation. So I'm going to start with equation number 1. Y equals 2x plus 4. I'm going to isolate. Left side equals y. Right side equals 2x plus 4. The left side becomes y is equal to 8/3. The right side becomes 2 times, but instead of x, I'm going to put negative 2/3 plus 4. 2 times negative 2/3, we have to remember that this is the same as 2 over 1. So 2 times negative 2 is negative 4. Over 1 times 3 is equal to 3. And I might as well change this into a common denominator of 3. And instead of 4, remember that's 4 over 1. So I multiplied the 1 by 3 to turn it into the denominator of 3. So I multiply the 4 by 3, that gives me 12. Negative 4 plus 12, add the numerators, ends up being 8. Keep the denominators, we end up with 8/3. Left side equals right side. So that means that this point is on this first line. That's what we've shown here. But we're not done. We have to repeat this. We have to do this for both. Let's make myself a little bit more room here. Just going to remove that. We've been looking at that a number of times already. Okay, so now equation number 2. Equation number 2. Y equals 2 minus x. Left side is equal to y. Right side is equal to 2 minus x. Y is equal to 8/3. Right side is equal to 2 minus, and instead of x, I'm going to put negative 2/3. 2, well again, I'm going to have this common denominator of 3, so I might as well just go ahead and change this. 2 over 1 becomes what over 3? That's the same as 6 over 3. A negative and a negative becomes a positive. And that is equal to 6 plus 2 is equal to 8 over 3. Left side equals right side. Check. Both sides have been, both equations have been verified. Therefore, the solution was negative 2/3, comma, 8/3 is a solution. So whether you have nice numbers, as in our first two examples, or whether you have fairly unpleasant fractions to work with, as in this example, you can use this verification both to just show that your solution works in another way, and also just to verify that the work that you've done was actually correct. Okay, that's it for this tutorial.